Hello everyone, welcome to Equal To, and this is the 11th episode of our number systems playlist, and we have been solving questions from exercise 1.3. We have solved 5 questions so far over the last 2 videos, so if you haven't seen those yet, you can go and watch that. Now in this video we are going to solve the rest of the questions in this exercise, which starts with question number 6. Okay, let me just read the question first. Look at several examples of rational numbers in the form of p by q where q not equal to 0. Where p and q are integers with no common factors other than 1. Okay, so this is the point that you have to know. With no common factors other than 1. And have terminating decimal representations. Can you guess what property q must satisfy? Okay, so this is the question. Now, first let me take several examples of rational numbers with no common factors other than 1. Okay, let us write those numbers. For example, we could take 1 by 2. So 1 by 2, is it a rational number? Of course yes, because p equals 1, q equals 2 and q is not equal to 0, so it's a rational number. So that is one example. Another number that you could think of is 1 by 3 you might think, but 1 by 3 is actually not a rational number because it's a rational number of course because p and q they are integers and q is not equal to 0, but it is not having terminating decimal representation. Okay, so when you expand 1 by 3, what would you get? It is 0.33333, right? Okay, so it keeps on going, so it's non-terminating. So 1 by 3 you cannot consider it. Okay, I hope you get that. Now 1 by 4. 1 by 4 is of course a rational number. 1 and 4 are integers and 4 is not equal to 0. And also the decimal representation of 1 by 4 is clearly not non-terminating. It terminates. Okay, so we know that. Okay, another example could be 1 by 5. Now let me just write the decimal expansions below. 0.5 this is, and this would be 0.25, right? And this would be 0.2. Now these are the decimal expansions of those fractions. Okay, 1 by 2, 1 by 4 and 1 by 5. So these are few examples. Now let me also take 1 by 10. 1 by 10 is of course rational and also what? It's terminating. Its value is 0.1. Right. So let me just stop here. We have 4 numbers whose decimal expansions are terminating. Okay. And these 4 are of course rational numbers. So what is the thing that is common to all these numbers? Let us just observe the denominator here. We have 2, we have 4, we have 5 and we have 10. Okay. Now what they are trying to tell is that these numbers have a pattern. Okay. So they are of the form 2 power a times 5 power b. So this is the observation that you could make. Okay, so these q numbers, they are of the form 2 power a into 5 power b. Like, can we actually write these numbers in that way? Let me check. Okay, we have 2 can obviously be represented in this form. It's 2 power 1 into 5 power 0. 5 power 0 is 1 and that gives you 2. Now the second number is 4, which obviously is 2 power 2 into 5 power 0. And the third number is 5. Okay, so that is 2 power 0 into 5 power 1. And the last number we have is 10, which is 2 power 0 into, 2 power 1 into 5 power 1. That gives you 10. Okay, now if you take any other number that is terminating and it's a rational number, so let us take 1 by 20. Okay, in that case it would be what? 2 power 2. That is 4 into 5 power 1. Okay, that also is obviously in this form. So what you can tell is that the q must satisfy the property that it should be of the value, it should be of the form 2 power a into 5 power b, where a and b are integers. A and b are integers. Okay, and it is of the form 2 power a into 5 power b, the value of q, where it has no common factors. Now all these examples that we have taken above has no common factors with p and q, and also they are rational numbers and they have terminating decimal representations. Okay, so for example, if you take 1 by 3, this property wouldn't work. Why? Because 1 by 3 is not actually terminating. It's non-terminating, but it's repeating. Okay, so hence it's obviously a rational number, but it doesn't satisfy this property. Okay, that is it for this question. Let me move to the next question real quick. And the next question is, write 3 numbers whose decimal expansions are terminating and non-recurring. Okay, we have to write 3 numbers whose decimal expansions are non-terminating and non-recurring. Okay, sorry, I think I read the question wrong the first time, so it should be non-terminating and non-recurring. So what they basically mean is that write a few examples of irrational numbers, because it is non-terminating and non-recurring, right? So it basically means those are irrational numbers. So you can just straight away go and write a few numbers that are irrational. So imperfect squares are basically irrational. So you could find the expansions of those, or you can just start imagining and writing right numbers 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I am not sure why I placed a comma here. Okay, so this is also a non-terminating and non-repeating number. Anything that you could think of is non-terminating and non-recurring. Okay, so that might be an example: 3.14, 15, 16, 17, 18, 19. This also is non-terminating and non-recurring. Okay, so it's there is nothing for you to think here. It's quite simple, and you can write whatever you want. It doesn't matter. It just basically have to be non-terminating and non-recurring. So these numbers are basically irrational. Okay, right. So that is it for this question. Now we are moving to the next question in this exercise, which is find 3 different irrational numbers between the rational numbers 5 by 7 and 9 by 11. Okay, you have to find 3 irrational numbers between the numbers. In the previous question, we found 3 irrational numbers, but we weren't given any condition for them, right? So they are in different ranges just from our imagination. Now, in this question, they have given that these irrational numbers should be in the range 5 by 7 and 9 by 11, within those. So we first have to find the decimal expansion of 5 by 7 and 9 by 11, right? So let me just find that out now. 5 by 7, that is 0.7 times 7 is 49, that gives you a remainder 1, and it's 0, 7, 1 is 7, that gives you a remainder 3, 0, 7 times 4 is 28, that gives you 0, and 7 times 2 is 14, that gives you 6, 0, 7 times 8 is 56, and that gives you a remainder remainder 4, and this might keep on going, but for our sake this value is enough. 0.71428 is approximately the value of 5 by 7, right? Okay, we know this. Now let us just do the same for 9 by 11. Okay, we don't need the exact value because we are just going to use that to find number in between. Okay, so we don't need the exact value, so I haven't calculated the entire thing, but let's just keep going. So it's 9 by 11, which is 0, 9. Okay, 11 times 8 is 88, and that gives you a remainder 2. It becomes 0. 11 times 1 is 11, that gives you a remainder 9. It becomes 90, and 11 times 8 is 88, that gives you a remainder. Okay, so it keeps on repeating. So it's non-terminating but repeating. Okay, so the value of 9 divided by 11 is equal to 0.81 bar. So it goes on like 81, 81, 81, 81. Okay, so these are things that we already seen. I'm just moving on with the solution. I hope you have watched all the videos from this playlist already. Okay, now we just have to find a number whose value lies between these two numbers. Okay, its value should be between those numbers. Okay, so what can we do? We are just going to find 3 numbers, right? Let the first one start with 0.72. Okay, 0.72. Obviously, it is greater than 0.71428 or whatever the number of digits that come after that, and obviously it's lesser than 0.81 as well. Okay, so 0.72, and obviously we need irrational numbers, so it shouldn't be terminating, it should go on, right? 0.72, 14, 15, 16, 17, it keeps on going. Okay, so that is one irrational number that is between the range 5 by 7 and 9 by 11. And let us come to the second irrational number, and that can be 0.73, and the third irrational number can be 0.74 or 75 or 76 or anything up to, like, it's just up to your imagination, right? And you obviously have to fill the following digits as well. It keeps on going. You just have to tell that it is non-repeating and it should not repeat. Okay, and here also let the digits keeps on going. Okay, so these are three irrational numbers that lie in between the range 5 by 7 and 9 by 11, and that is the solution to this question. I hope you understood this. We just found the decimal expansions for the numbers 5 by 7 and 9 by 11, and we just made out three numbers in between that range, and that would be our answer. Okay, now moving on to the last question of this exercise. We are given 5 subdivisions here. So what we have to do is that we have to classify these numbers as rational or irrational numbers. Okay, so let us just do that. It's quite simple actually. The first question is 23. Now 23 is not root 23, right? Root 23 is irrational. Why is that? 23 is not a perfect square. Sorry, I'm not sure if you are able to understand this. I'll write it again. So 23 is not a perfect square. So what is a perfect square? Square root of that number should be a whole number, right? So 23 doesn't do that. So 23 is not a perfect square, and square root of non-perfect squares are irrational. So this one is irrational. Okay. The first one is irrational. Let me just move this over there. Sorry, it should do the entire thing. Okay, so root 23 is irrational. Now we are moving to the second subdivision, which is root of 225. Square root of 225. Okay, square root of 225 is actually 15. It can be plus or minus 15. But either way, it is a rational number. So the second one is rational number. And the third one, moving on to the third one, its value 0.3796, and 0.3796 is obviously terminating, and since it is terminating, you can tell that it is rational. Okay. Now we are moving to the next subdivision, which is the fourth subdivision, and that is 7.478478, and it goes on. Okay, now what you can see is that it is repeating 7.478 bar. So 478 is the repeating block. Okay, 478 keeps on repeating. So the next digit would be 4, then the digit after that is 7 and 8, and it goes on. So 7.478 bar, and since although it is not terminating but it is repeating, it is rational. It is a rational number, right? Now we are moving to the fifth subdivision here, which is 1.10101000100001. So basically it keeps on going and there is no repetition here. So it is non-terminating and non-repeating, and hence it is irrational. Okay, so that is it for this question, and we have covered 4 questions in this video. I hope you understood these, and that is the end of this exercise. If you have any doubts in the questions that we have discussed in this video, please put them in the comments. I'll get back to you as soon as possible. And also I hope you have seen all the videos previous in this playlist, and we have covered the entire exercise 1.3. So that is it for this video. If you have any questions, please feel free to put them down in the comments. I'll get back to you as soon as possible. Thank you so much for watching this one. See you in the next video. Bye for now.